Hello everyone, and welcome to another edition of the Metal AM webinar. It's our great pleasure to welcome back Alejandra de Hija from HP, Fabio De Falco from Legor, and today joining us, Thomas Layman from AnalogLab. Today they will be presenting the Amano project, and now I'd like to hand over straight away to Fabio. Thank you.
So good afternoon to everybody, and thanks Martin to introducing us and myself. I'm Fabio De Falco and I'm marketing manager at Legor. So I'm going to share my screen in order to start with the presentation. Just 1 second. Okay. You can see my presentation?
Excellent. Thank you, Fabio. Thank you.
Perfect. So before to start, I would say that it's a really big pleasure for me to be here in front of you, talking about and presenting to you this project that we name Beyond Extraordinary. But before to go deeper into the core of this presentation, I would spend just a few seconds to introduce our company, so who we are. Legor, it's a company that is specialized in transforming metals into master alloys, powders, and galvanic solution for jewelry, high-end jewelry, and fashion accessories industry. So we used to define ourselves as specialists in precious metal science, but as you probably can imagine, today we are not talking about master alloys or galvanic solution, but we're going to talk beyond extraordinary. So, and what does it mean for us, beyond extraordinary? Beyond extraordinary is an invitation to start thinking differently in order to step outside traditional frameworks, thanks to the adoption of some innovation like 3D metal jet printing. So, but before going ahead, I would say that when we established this partnership with HP 5 years ago, our aim was to introduce this technology in our industry. So fashion accessories and jewelry industry, in order to be a catalyst for innovation. As you probably know better than me, innovation is really important. And for us, it's a driver, is a pillar of our development and also to be into the market in the next future. So this was our first idea. But second point, we want to be a catalyst and we want to facilitate the integration of this cutting-edge technology and the artistic and creative vision of the designers. And this is a really crucial and important point, because when we brought this technology in our facility, immediately we noted that this technology is not just related to manufacturer companies, but it speaks directly also to the designers. Because thanks to this technology, we were and we are able to reimagine how to design a product, because there are a lot of advantages, a lot of benefits that can allow designers to create something really different, to handle some complex geometry that cannot produce with the most common technology. In this chart, you can see something that we realized last year. This was part of a previous workshop that we already have. And as you can see, this typical shape it's really difficult to realize with the most common technology present into the market, like, I don't know, CNC, a laser technology, or casting on whatever. That's why what we noted was that different design concepts that are really common and already used in other industry like aerospace, automotive, like, I don't know, generative design, topological optimization, lattice structure. Now, thanks to this implementation, can be applied also to the more static, let's say, markets like jewelry, watches, and fashion accessories. So that's why all those elements that brought us to define and to write down a value proposition that we can sum up through three main pillars. And so we can talk about agility, creativity, and sustainability. Agility, because according to us and based on our more than 3 years of experience with this technology, now we can say that is really a fast technology. We do not have limits in terms of time or capabilities. That's why, and also it's a digital technology. That's why we can define agile. We do not have any minimum order quantity, for example. So we can produce and we can print 1 piece, 5 pieces, 10 pieces, but also 100 and 1,000 pieces. Creativity is the core. Because at first, as I said before, the freedom in terms of design, it's really high. Also the mass customization. So we are able to customize the object directly during the printing phase. And it is also sustainable because we can reuse the powder. We do not have waste scraps and whatever. But even more, we can simplify the overall supply chain. In the next chart, we can be more granular, talking about the main benefits that bring us to define this value proposition. So you need to consider that the technology doesn't need any kind of stamp, no mold. That's why we are able to deliver, to produce the object in just 3 days. So starting from the 4 days, we are able to deliver 500 pieces, 1,000 pieces. We can do running changes to the design. It's a digital technology. We can produce multiple parts and we can stack the object one on each other, and we can produce different objects in the same printing job. We don't need any kind of support if we can compare this technology with, I don't know, laser technology, talking always about additive manufacturing technology. We can reuse 99% of the powders. In terms of quality, today we are able to achieve a fully dense object, 99.9% of density, meaning that no residual porosity. We can create a chained, half welderless object, and we can customize the object, as I said before. And when I said, okay, we are able to simplify the overall supply chain, we can define the new supply chain in this chart. So there is the brand idea that have been designed for additive. Then we can print. At the end, we can treat the surface like a normal object. So we can polish it, we can plating it, we can apply PVD coating. As you can see here, it's really fast. Also talking about supply chain. But so that's why, before leaving this stage, the next speaker that would be AnalogLab, at the end, I want to sum up free space for creativity. But we already have some different workshop, and until last year, all those kind of concepts seems to be, just words on a deck, just some words on a presentation. That's why I'm really happy today to introduce Amano Plus and AnalogLab, because for us, it's in a certain way, we are able today to demonstrate that all these benefits and all the concepts that are behind the metal jet technology can bring idea to life. In fact, when me and Thomas meet each other last year, at that time, Thomas were looking for an agile technology to bring his ideas to life, to create something different in an industry that is watch industry, that it's really in a certain way we can define static, let's say. But on the other hand, Legor, so we want to be and to connect not just with manufacturer company, but especially with visionary designers. That's why at the end, our meet with the ideal mix, this collaboration represents for us a perfect blend of craftsmanship, exclusivity, and innovation, because we were able to create the perfect mix between artisanality, design, and technology. So now I'm really happy to leave this stage to Thomas from AnalogLab. Thanks for your attention.
Fabio, thank you so much for that wonderful introduction. I really appreciate it. I'm just going to, if you're all right, we'll just go right into the slides. I think they're fairly self-explanatory. My name is Thomas Layman, and I'm the founder of AnalogLab. We're a traditional, or I guess we would say now, a non-traditional design firm. And what we're talking about today is the birth of an idea, which is the foundation for this presentation. And we're a Milan and Seattle-based design firm, and I've been a designer and educator for more years than I'd like to admit. But for over 15 years, we've been Milan-based, and we've developed branding designs and strategies for a wide range of companies, including companies like Ferrari, Maserati, Nike, Prada, Starbucks, etc. So at some point, we decided that what we wanted to do was look at projects that could be something that we could own, that we could control as we're going through it. So Amano Plus is a passion project, and it comes from my curiosity, which is really to always be pushing the studio to drive beyond our creative boundaries. And we were really early adopters in 3D printing. I actually went to Brooklyn and bought a printer from the garage of Brie Pettis. And I don't know if you guys know who he is, but he was the founder of MakerBot many, many years ago. And while the machine itself didn't really ever work or produce anything, it was the step into the process of understanding how this works and how the future is going to be. So that stimulated my curiosity. And since we work in jewelry, furniture, lighting, and product design, we set out to create this studio design collection of mechanical watches. Mechanical watches, for those of you that don't know, are movements that are hand assembled, generally mechanically driven, generally from Switzerland. So we had this deep desire to try and create something that was a really interesting marriage between the absolute craft of watchmaking, orologi, and the ability of 3D printing to create something that is kind of a mass customization on demand sort of possibility. So that was kind of the birth of the idea. And it's really a fusion of this tradition and innovation. And when we call our company or our product Amano Plus, we mean it's because Amano reflects our deep belief in the timeless values of handcrafting. In fact, one of the reasons I live in Italy as opposed to living in the United States is that tradition and that craftsmanship is still incredibly evident in everything you do here in Italy. And it's something that stimulates me daily. But we wanted to bring this ability of this kind of future forward 3D printing technology and see what we could do to marry those two things together to create something that hasn't been seen before. And so after 3 years of design and development, we've created the first ever 3D printed stainless steel timepieces. And we're very proud to say they're made in Italy. Fabio's group prints it. It's done in a very sustainable way. So that's one of the key benefits. A second thing we're always looking for is ways to utilize the minimal amount of material. And so this is a second thing that's a great benefit of this material. And through the partnership with Legor and HP, we've arrived at a level of precision and a level of a very refined process to create something that hasn't been seen before in the marketplace. And I believe there'll be more and more entrants in the future. But the idea is to challenge traditional watchmaking while preserving the heritage. And this technology gives us the opportunity for each watch to have a distinctive form, texture, and finish, and create a one-of-a-kind timepiece that can't be replicated ever by traditional methods. This hybrid process blends modern manufacturing with precision craftsmanship, enabling designs that would otherwise be impossible to produce. What you just saw there was, and I'll go back just a second. This would be just a screenshot of the database that we use to build this model that we send to Fabio and the team, and they take this as a digital form and create something physical in stainless steel for us, which is also a new step forward and a very interesting process. And one of the things we're able to do is work with the texture and the result of 3D printing, which I believe is something that's a new design language. It has a certain look, a certain feel, and then it allows us this incredible freedom to add textures which we could never do in any other way. Here you see 3 examples from the current watch collection we're working on. And all of these are straight out of the printer with a little bit of sandblasting to give them a final finish, but this is exactly how it's finished. And what's interesting in this is that we add our process of CNC post-processing, which brings very bright and shiny and kind of brilliant areas to the project also. So there's this really beautiful contrast of super refined and a little bit grezzo, as you'd say, or rough in the business. So so the benefits of this is it enables designs beyond traditional manufacturing methods, uses recyclable materials, and creates minimum waste. We can create this unique texture and surface finish, openings, and since it doesn't need support, we can have almost complete freedom in the design we're doing. And we incorporate this idea of CNC post-processing and hand finish for the total look of precision craftsmanship. So each Amano timepiece, most importantly, is customizable by our customer, you, with our online configurator, allowing you to create your very own bespoke timepiece. And again, this, as we grow our library of designs and our library of ideas, creates something that can be very compelling in the marketplace. We're currently in pre-launch phase, and our first collection is right now. We'll ask Fabio at the end of this conversation where we're at, but we're very close to finishing our final details on the work that we've been doing back and forth, which has been a really interesting and precise and well-supported process by Legor and HP. And I have to say I'm super appreciative to that. So the next step for us is to really start to look at what are the possibilities. The plan is for Amano Plus to start with timepieces. There's a couple of reasons. There's a possibility to control the costs because of the size and the cost of the printing, but secondly, also because of the quality and the craftsmanship and the handwork we're putting in it to actually gain a fairly premium price. So we look at these two kind of balances as going forward, that this is just the start of where we're going to go with this brand. And I have to say, honestly, that as we go forward, I'm always impatient to try and move faster and try and get things done sooner, and learning step by step to get things in the watch industry perfect is the most important thing you can do. So each timepiece is brought to life by you, our customers, by utilizing our online configurator, allowing you to be a partner in the creation of your timepiece, which to me is a very important thing. The result is a timepiece that is completely unique in the watch industry, allowing our customers to create their own bespoke timepiece. We call this process tailored time. It's a little hint to the way things are done in Italy. While we are at the beginning of our journey, the response that we've had so far has been super positive. These are just some quick sketches of where we're coming to in the future. We have, almost unlimited possibilities to create new ideas and to provoke this market that is very, as Fabio mentioned, very static and very straightforward. So there we get to see it again. This is the basic database of a 42 millimeter watch body, and there's a lot of, if you look, there's a couple of little details, like we're able to print the openings to be able to hold the watch strap. We'll be able to print the opening to be able to mount the stem holder. All these different things that are really things that are done in post-processing. Normally we can get to a certain point of precision with the HP and Legor process. Here's a couple of pictures of some recently completed stainless steel parts. And this is just a basic breakdown of all the assembly pieces that we use when we put it together. It starts with sapphire crystals and the 316L stainless steel body, which also we're working with Legor to work with the bronze, which we think would be very exciting. Obviously, then we add the watch face, custom crowns, a Swiss movement, a mounting insert, and then the back with sapphire gaskets. So it all comes together to create a waterproof, almost permanent watch piece that's on par with any watch that's made today from a quality standpoint, but that's completely unique from a look and feel. So what's important to us? It's 3D printed, it's stainless steel, it's made in Italy, it's 100% configurable, it's hand assembled, and it uses, as much as possible, sustainable materials. Every day that drive is going forward, so we're always looking for ways to create a more sustainable project. For example, our watch straps are made from cactus. So we have a vegan watch strap that uses cactus leather, as we'll call it. And we'll have two sizes. We have a 37 millimeter, a 42 millimeter, and two different types of backs, a crystal back and a solid stainless steel back. And these are 4 images of the 4 collections. You can see the chapter rings. Each one has a completely different pattern and texture, and these are printed right into the body when we make them. And the chapter rings look like this, and they really express what's going on with the tonality and the design of the project. And these are just quick so you can see the front and the back, and I'll go through these really quick. This is one we call Pure, which is we're just using the unadulterated, no texture, just capturing the texture that comes from the 3D printing on the sides of the watch body, and you can see this contrast between the matte and the shiny. This is one we call Geo, and you can see it has a geometric pattern. This is one that is really beautiful in person. It's water, and it really has a beautiful flow. And the last one is called Voronoi. And Voronoi is an abstract pattern that we control very carefully to get this look and feel. We do all of the database we build in-house. We print probably 25 or 30 samples before we get to the final one. Thankfully, we start with plastics, and then we move into stainless steel and metal so we can really see how it looks. And then once we get to the final one, we turn it over to post-processing, which does the CNC work to fit the crystal in a very precise way and fit the mountings, etc. And this is just a quick screenshot of the online configurator, and you can see it's a very beautiful 3D representation of exactly what you get when you go online to order. And I think that's it. Are we done? Yep. Thank you very much. And I think we turn it over to Alejandra now. Is that right?
Yeah, correct.
I didn't go too long. All right.
Yeah. Let me share my screen here. Okay, can you see my screen?
Coming.
Yes, Alejandra.
Okay, perfect. So no, thank you, Thomas. I really wanted to say thank you here. It's really amazing to see your beautiful designs coming to life and to see how you keep on iterating on different ideas. I can say I saw the watches in real life and they look amazing. So yeah, no, this is Alejandra from HP. I work as a 3D metals application engineer, and from HP side, what I want to present is the latest news that we have for our HP Metal Jet technology. So I will be covering today a bit what's the latest trends and opportunities that we are seeing in the watch, jewelry, and fashion accessories industry, and what are the customers asking from us in this field. I will also be presenting the new platforms solutions that we have developed that go around with our printer. And finally, and moving to the fun part, I will be showing some real case examples of how we are using
Alejandra,
yeah?
Sorry, put in presentation mode the deck. It's not in presentation mode.
Okay, that's weird. I have it here in presentation.
No.
No?
No, we are just watching the PowerPoint.
But are you seeing the presenter slide or the commenter slide?
Commenter slide.
So I have to just swap. How about now?
Same.
Okay.
Same.
This is weird. Why is this happening? This was not happening before.
This is the charm of live TV. Okay, now it's good, Alejandra.
Now it's good? Perfect.
Yeah.
Cool. No, sorry for that. These things happen. So yeah, let's get started. So we don't start we don't waste time here on the value proposition. I know Fabio and Thomas have been covering a little bit here on the value proposition, but I want to reinforce some key messages. So we know that HP Metal Jet stands out in industrial 3D printing, and the reasons is starting with our print heads and with our binders. We are technology leaders for both assets, and the combination of both ensure accuracy, reliability, productivity, and consistent part quality, which really makes large-scale production efficient. From HP side, we count with tons and tons of manufacturing expertise over past years, where we have really printed millions of 3D parts. And we have used all that knowledge into making our platform more and more robust. And also important to highlight here the long-term stability from a brand like HP that's bringing to the additive ecosystem. We are global technological leaders, and we keep on investing on innovation. So something else that this industry is asking for is agility in production, and Thomas' example was a great example of this, right? The industry, which is calling it the kind of like the fast fashion, the brands wants to launch a new collection in spring, another collection in summer. Sometimes they want new collections every single month. So for this reason, fast time to market is super important for them. And HP MetalJet really accelerates the product development cycles, reducing the lead times compared to traditional manufacturing. Then design iterations can be done very quickly, and you saw also the example from Thomas. You can print different designs, different concepts at once, and really get feedback from those iterations very quickly. And also in this agility, it's super crucial to count with partners like Legor that can offer the full end-to-end supply chain solution to the customers. I can really say they do deliver parts in a few days, machine, post-processed, 3D coated, polished. So it's amazing to count with partners like Legor that can really work so quickly in this market. Now, you may think that all of this is common to other additive manufacturing technologies, but what makes HP MetalJet a good fit to solve all of these pains is the combination between productivity that allows efficient cost in production, together with a superior surface finish. And this is especially compared to laser powder bed fusion. And last but not least, sustainability. I was loving Thomas' speech, talking and insisting in how important for him and for the brand is to design sustainable and to produce sustainable products. And it is important for almost every company we are talking today. So our solution really allows to reuse excess powder, and there is a reduction of scrap waste compared to conventional technologies. And in terms of materials, more and more customers are asking to use recycled materials, like the case we just saw from Thomas, right? So also something that we are seeing in this market is, especially in the kind of like accessories market for fashion, many customers are switching from brass material, which is a material that's pretty complex to recycle, to a stainless steel, which makes BinderJet a great fit for this type of products as well. So as probably most of you know, HP MetalJet is based on BinderJet technology. I will not be covering in detail how BinderJet works. We have many webinars on that, and feel free to sing with me if you have questions. But I want to just reinforce that the technology itself. Wait, because my screen just froze again. Now, the technology consists in 5 basic steps. So we start by loading the build unit with the material that we want to use for that print job. Then we move into the printing phase in the printer, which is where the main magic is happening. Then finally, we move our build unit to the current station to make sure that we obtain strong green parts. And then we move into the excavation phase, where we extract the green parts from the build unit, and we put them into the sintering furnace to achieve the final mechanical properties of the parts. For some reason, my laptop doesn't want to cooperate today. Okay. So in 2022, we launched the S100 system, and recently, just a few months ago, we have launched new modular solutions and new modular platforms that go along with the printer. These platforms are represented here in this table over here. And I really want to reinforce that for the 3 different platforms, the printer together with the build unit remain the core hardware assets, and they remain unchanged independently from the platform configuration. So for the first platform, which is the one on the first column on the table, the S100D, where D stands for development, it integrates the curing process inside of the printer, which makes it ideal for research institutes and material developers, since it offers a cost-effective entry into BinderJet technology with minimal investment in hardware. Now, the second platform, which is represented in the 2 central columns here, the S100P, where P stands for production, it has been designed for a scalable production. Let's say it's ideal for low to mid-volume production or high-mix, low-volume. You can consider 2 to 5 jobs per printer per week. And it is a great choice for service bureaus, for original equipment manufacturers, for small contract manufacturers. The platform itself includes partnerships with Volkmann that has developed a low-cost and semi-manual powder handling solution that's fully compatible with our build unit, and also a partnership with Sinterson, who offers an affordable and sintering furnace. And finally, in the last two columns, you can see the S100M, where M stands for mass production. Is basically the initial configuration that we launched in 2022. And it is ideal for customers with high mass production volume. So we can consider between 8 to 10 jobs a week. And it comes with fully automated powder loading and depowdering stations from HP. So what I really want everybody to remember from here was the key takeaway is that the printer and the build unit remain the same, exactly the same hardware units throughout the different configurations. So like these customers can start with a minimum setup and upgrade with additional hardware equipment as the production scales based on their demand from the customers. Okay. So now moving to the fun part, me as application engineer, I always love this part the most, which is design. Something new that we have launched into the market is the HP 3D Digital Texture Library. This is a collection of over 100 different textures that customers can easily download directly from our website. You have the link over here, and they can directly apply those textures to their designs. What's great about these textures is that they are fully customizable, so you can really adjust the size of the pattern, depth, and like this, you can make the designs unique. Then for those designers that are looking into getting a little bit more hands-on, kind of like touch and feel, we also offer a booklet that's available for purchase with the 3D printed patterns in polymers, so you can get more familiar physically with the texture before adding them to your projects. And then finally, for those customers who just want HP to take care of the texturing services, we can provide these texturing services as a service. And here in this image, you can see an example of products for a confidential customer I'm working on the moment in the consumer industry, where we apply these textures in a series of their stainless products, and the products really turn out great, as you can see here in the picture. So we know it can be a bit overwhelming to download over 100 different textures and experiment with them one by one. So for this reason, we also partner with Leopoly to develop a powerful visualization tool, which you can see here in this video. The beauty of this tool is that customers can easily just upload their own files into the website, into the tool, and visualize in real time how different textures will look, and like this make the selection process of the texture way more efficient. So now, while the textures will allow kind of like a new degree of customization in 3D objects, we are also pushing the boundaries of design with the newly developed texture 3D print solution, which is based on AI technology. So let's face the truth: most of the industrial and mechanical designers are more familiar with subtractive design tools rather than with 3D design tools, right? And this skill gap is really limiting the adoption of additive manufacturing. So for this reason, from HP side, we really saw the need to develop the texture 3D print solution, which really enables users to create ready-to-print 3D models with simple text descriptions, and with this kind of like making the digital manufacturing way more accessible. And here you can see a couple of examples that I personally love. The first image on the left, it is a dragon that was designed by the daughter of one of our colleagues, 5-year-old daughter, just by entering some simple text script into the tool. And the dragon is amazing. It's really cute, right? And then on the right side, you see also a similar case for a drone housing that really was designed by a person that had zero CAD skills in just a few minutes. So now we know that there are several AI-powered 3D design tools in the market, and what's making HP solution unique is that it has the ability to be vertically integrated into the customer's organization. So this means that the AI can learn from a specific customer's needs and inputs in a private and secure environment without contamination from other, let's say, customers' inputs. Also, it implements design rules for additive manufacturing. So like this, we can guarantee that the actual generated models can be printed, can be produced. And another key advantage is that I really like this advantage is that it allows hybrid designs. So this will allow users to integrate existing geometries with AI-generated components. So in order for you to understand a bit better what I mean here, I have listed here a couple of examples. In this case, for instance, we are feeding the tool with a standard eyewear frame. Let's say this is like an iconic standard eyewear from a customer, right? And the customer doesn't want the frame to be changed dramatically. So to preserve the iconic design, we mark the areas that must remain untouched, ensuring that the key brand elements stay intact, and at the same time, we define the sections that can be modified. And then we input the text. In this case, we said we want to create a pair of glasses with dragon scales, and here you see the result. Another example here for a lamp where we have the base of the lamp created, and we just want to play a bit with different shades for the lamp itself. So we input the model, the 3D model of the base of the lamp. And we mark which areas need to remain untouched and which areas can be modified. And in this case, we wanted to create a latticed wavelength lampshade. So here you can see one of the examples that the tool provided. So how the tool actually works, I wanted to showcase a real case video. This live demo in real time. And what we do is here in this text field, we input the words that we want to design, right? So in this case, we want to design a carving of an apple. The tool automatically generates 4 2D images that the customer can choose from based on what it represents better what that person had in mind. And once you have selected the 2D image that you like the best, you just click Generate 3D. And in just a few seconds, you will see it comes up with the 3D printable file. We showcased this video at Fornext in autumn last year for over 400 different times, and the feedback that we got from the market was really positive. So yeah, looking forward on how this will help us to scale further in the market. So yeah, with that, I really want to thank you all for your time today. I also really want to thank Thomas' passion to embrace our technology in his product portfolio. I really hope this session has given you a clear understanding of how you can fully take advantage of our HP Metal Jet solution and unlock new opportunities. And if you have any projects that you would like to explore with this technology, feel free to reach out directly to Fabio from Legor or to myself. And we will really love to discuss how we can support your ideas. So I think
thank you.
Yeah, Martin, the floor is yours.
Sorry, thank you, Alejandra. That was wonderful. And also Thomas and Fabio. There's been a few questions that have come in during the presentation, and actually there's been a few questions that were emailed to us prior to the presentation from some of the people that registered. So I'll just take you through some of those. But starting from the top, Lauren was asking about small batches and individual batches of custom pieces. And I'm guessing I'd kind of open that question up slightly larger in terms of how you would decide when you would decide, start a particular batch. Do you have to say, okay, we'll run with 1 watch, 5 watches, 100 watches? How is it that you decide those kinds of things?
Was that sent to me, that question?
Well, I guess it's to yourself and to Fabio, really, I suppose.
Yeah.
Who's controlling that step in the partnership, really?
Well, actually, the most interesting part of it is that since it's all database controlled, it's controlled by the buyer, the customer. So the customer goes in and configures exactly what they're looking for. This generates a database that then is transmitted, checked by us and transmitted to Fabio and his team, and then they print them. Now, we will, for economic sake, batch them in groups of 25 or 100 or whatever we feel is the most beneficial at the moment. But the basic process is really the buyer is in control of how the process goes forward, and which is much different than the traditional production process, where we would have a prototype, then we would have to do machining, then we would finalize that, then we might make a mold, we might CNC things. So we're looking at 6 to 8 weeks. And in this case, we're probably looking at a 2 to 3 week lead time for everything. Remember, we source all of the Swiss components for assembly. So the watch body is the key component and the most interesting component, but the other components all come together to make the watch. So obviously there's some benefits, honestly, for us to source them in groupings and not to buy them one off at a time. Mm-hmm. But the goal is to move through this process and get a system moving with Legor, where we're producing, I think we've been talking in the 50 to 100 unit range to begin with.
Right.
And hopefully doing those, at least 2 or 3 times a month.
Okay. And then following on from that, Elena, is asking the question about how long it's a process. And I'm guessing that's sort of like, how long is the lead time as well? So if we were ordering your watches today, how long will it take before they turn up in the customer's hands?
Yeah, I can answer to this question. For us, the entire process, and I'm talking about, printing, curing, and sintering the object. It takes 3 days, because one day we're going to print, the second day we are going to curing the object, the third day we are going to sinter the object. So that's why, starting from the 4th day, we are able to deliver a piece, the object, that is a rough object. Because sure, if you want to have a mirror finishing, or you want to play the object, you want to apply a PVD coating, the time will be longer, because you have to treat this object. But at the end, if you love the sandblast finishing, it takes 3 days.
I guess that's really quite an incredible advantage, though, when you compare that. Perhaps, Thomas, you can comment to the traditional route of producing a custom-made watch. 3-4 days, even perhaps a week, seems like an incredibly short period of time, when one might expect to wait probably months and months for a traditionally manufactured custom watch.
Traditionally, in the watch industry, and Fabio comes from the industry also, I think we would be looking at a 3-month wait time in the traditional watch industry, and that would be fairly fast. So 3 days as opposed to 3 months is incredible. Yeah. Now there's a caveat there that it leaves Legor in a raw state, and so there's, as Fabio mentioned, post-processing, assembly. We're very careful. We work with our watchmaker to make sure that it's tested and assembled correctly, etc. So, to be really honest, in a best case scenario, it's probably about a 14-day process from start to finish.
Yeah, I think that's pretty reasonable, really, though.
Yeah. The other benefit and advantage is that usually, if you want to produce something with, I don't know, MIM or whatever, anyway, there is a minimum order quantity to be, accessible and also convenient. Yep. So in this case, and this is the real, advantage, that, as I said also during my presentation, we can produce 5 pieces, 4 pieces, 100 pieces, doesn't matter.
And I will add something that's really important to think about for people that are thinking about these type of processes. When you run down the road of MIM, for example, you're making a very large upfront investment. And as a designer, I can tell you very honestly that it's very rare that things are perfect the first time. And there's always needs to be changes and adjustments. And one of the key benefits of the 3D printing process is this ability to rapid iterate and to rapidly see where you're at with it, both from a visual and aesthetic point of view, but also from a very simple and important technical point of view. How strong is it? Is it going to allow for wear and tear, et cetera, et cetera? So these are things that you would initially invest a lot in molds and injection and many, many, many weeks of waiting. Now that's getting quicker as their response to 3D printing, but still it's a huge upfront investment and it's a lot of wait time. And at the end, if it comes out and everything's right, which is very rare, we look at our iteration process as a minimum of 3 to 5 iterations before we come up with something that we feel confident is the precision that we have to have, can be something that we can actually offer to the buyer and something that they'll be in love with.
Right. So there's a question here from Chris, and I'll expand it with one of the questions that we had previously as well, in terms of the tolerances and the minimum feature size which you're able to generate with the binder jetting process in metals. But I guess also, if you extend that a little bit, watches are known for being precision instruments. So what kind of level of precision can you get from these things? And if you also link that to your comment in the presentation about them being 100% customizable, how customizable is that? How small does that allow you to go when you're customizing your design?
No, this is a great question, and I can get started, and then you, Thomas and Fabio, feel free to complement. So in general, the tolerances that can be achieved with our technology are, let's say, plus minus 1.3% the nominal dimension, okay, at 5 sigma repeatability. So yeah, in terms of feature size, you can consider around 0.2 millimeters is something that we can achieve with our technology today, which is a pretty good level of detail. And yeah, it's true for the watches industry. There is going to be some level of post machining needed, especially in the area where the glass is going to be mounted, to meet the tolerances needed for the market. But still, this is way more sustainable and way more efficient than just maybe like CNC machining from a blank the whole watch case body, or investing in a long lead time and high capex investment tool for metal injection molding. So yeah, for this industry, it really makes sense to go for the technology.
Yeah, I completely agree, and especially if you want to create some design, that you cannot produce with CNC, for example, you can just print the object, the case, then with the texture, the shape that you want, because we also produce some hollow watch case in order to have a lightweight watch on your wrist, and then you can just, machining it where you need. That it's totally different. At the end, you will have a really exclusive product with all the feature in terms of tolerances, precision that have been required from the object.
And from an outside perspective, and someone who's using the services, for Legor and us, it has been for sure a back and forth and a testing process to arrive at the precision. And that's one of the things that they've been very, very responsive to, is having a deep understanding of the needs of having the best precision that they can provide, and being willing to go that extra distance to make sure that we get what we need. The second part of that, though, is if we step back to the design process, you have to kind of design in for that imprecision. And that's an interesting process, because you have to kind of guess what's going to happen down the road and then work backwards to design in the pieces that you need so everything comes out exactly as you want it.
Okay. So in terms of the customization, though, element of the designs you show, you've got 4 standard models with the textures on. What are the elements of those designs that the people can customize, those using your platform?
Well, obviously at this moment there's sizes, and then there's the textures which are growing with, and again, we're in the pre-launch phase, so it's a testing and back and forth with Fabio and his team. But we come up with designs, we send them to those guys, we run it through the process, and we make sure that it meets all the criteria. Then we can add that to the database. Eventually, what's really interesting with where HP is going in AI, it might be that we can start to expand the platform to allow a little bit more customization within very tight parameters for the user to come in and actually work directly to customize. And for me, that's our long-term dream anyway, is to be able to get to a point where you can come in and you can decide, well, I like this as a starting point, but I'd rather see it a little bit this way, a little bit that way. Maybe the textures are softer, maybe they're deeper, and we can allow that very easily with the evolution of the platform. And so, I'm super excited to learn more about where HP is with this and how we can go forward and partner in developing it.
Right. So some interesting questions coming in about materials as well. So Emma, Attila, and Benjamin have all asked about different materials. Are precious metals possible? What other materials are going to be sort of researched and added to the collection, as it were? And I think titanium is particularly popular material in additive manufacturing. So I guess that's a common request these days. Perhaps Alejandra, you could.
Yeah, I can.
So
I
if
can
you
get
want,
started.
Alejandra, I will just answer saying that which are the materials that we are able to print right now, and then I will leave to you the stage for the other materials. What do you think?
Difficult version, right, Fabio? Okay, or yours.
So, actually, we are able to print, and we already printed stainless steel, 3/6 74 pH, and also bronze and silver, with really good result, especially with silver. Bronze, in terms of density, we are not say fully dense object like steel and silver, that we are really great level of quality.
No, thank you, Fabio. No, this is great. And I just want to compliment that from HP side, the initial focus was, of course, steel materials. We've done a lot of work on steel, and especially on stainless steels. And the beauty of our platform is that it is open in terms of materials development for our partners to play with different alloys. So that was the beauty of the partnership with Legor. Then be kind of like the main experts in precious alloys for this market is really allowing that customers get access to materials like silver that maybe from HP side we would have never envisioned, but this is a reality now, and we are seeing a lot of traction for silver projects in this field. In terms of titanium, it's a material that we are screening at the moment and we are investigating. It's a bit challenging for binder jet, given it's a reactive material, but it's definitely something that we are looking into. I cannot disclose more here, but if anybody wants to know more, feel free to sync with me and I can provide more information on a one-to-one basis.
Yeah, I coming back on the silver, yes, now there is a lot of requests, specifically considering that the cost of the gold is a little bit quite high today. So,
and it's true you do platinum also. Is that correct?
Yes, also platinum.
Wow, that's interesting.
One thing we think about a lot when you're talking about the advantages of titanium, one of the key advantages is weight. And one of the things you can do with this process is basically, as Fabio was talking about, hollow out the stainless steel, so you get the benefit of the strength and the beauty of the stainless steel, and matching very closely to the weight advantage of titanium.
Yeah. So one of the interesting things I thought about, Thomas, is you're obviously from the wider design world, from the sort of like artistic community. What other applications do you see that this kind of technology would be useful for in your particular field, expanding beyond watches?
We use 3D printing, I would say, every day. Our printers are usually running 24 hours a day because the process isn't super fast, first of all. But secondly, we found that it becomes an absolute proof of concept to be able to test everything. For example, we're working on a lighting system for an Italian client, and we've developed a special textured material that we will probably 3D print in stainless steel, and because it will have special reflective qualities, or maybe we could try it in silver. And so we see, that it's really an open opportunity. And the second thing is, in technology, you learn very quickly that it's going to move forward. It's never standing still. Costs are going to get more advantageous. Speed is going to get quicker, and precision gets always better. So we're kind of, Fabio, counting on that as we go forward, so we can start to expand the offerings that we have and create things that are even more complicated to do.
Right. We did have a little bit of a late start, so I think we can squeeze in just this last question, really, and that's really about the design guidelines. Any sort of limitations there are that you've run into using the binder jet sort of additive manufacturing approach? Is there anything that specifically you've needed to adjust in order to use this technology?
Yeah, no, in the end, each technology has their own design guidelines, and in the end, for binder jet, there is way more design freedom than with other conventional technologies, given the fact that there is no tooling constraints, so you're not constrained by a tool here. It is true that there are some design considerations to take into account, and these are mainly coming from the sintering process. So we have to make sure that we have a sintering-friendly design, and we have a sintering strategy for this. I invite everybody to watch Beyond the Forge webinar series from HP, where we do a deep dive. It's available on our website, and we do a deep dive on design guidelines for the technology to take these considerations into account.
Okay, so in terms of design guidelines, and does that include things like the surface finish? I know that Joseph was asking about the RA.
Surface finish is included here, yeah.
Okay, and is that dependent, for instance, on the powders that you use? So if you're using finer powders, you get better surface finish, or
more than the powders itself, it also depends on the orientation of the part and the design of the part, because in the end there is an inherent process, or let's say effect, that happens during the printing process for every additive technology, which is what the so-called stair-stepping effect, right? So the impact of the layering of the part. So depending on how you orient the part during the printing process, this can kind of like impact the roughness of the final surface. But in summary, with HP's technology, we are able to achieve one of the best surface roughness in the additive and the metal additive market. We are in between, I see the question is coming for flat surfaces, so we are in between 4 to 8 microns in RA, which is a really good starting point then to do the post-polishing of the parts.
And then I guess I was going to say, Fabio, can you work with that kind of level of surface roughness directly with other surface treatment techniques, or do you need to machine it first and do other processes before you
exactly, because as Alejandra said, in our case, we used to sandblast the object before delivering them, and we are able to just with sandblasting, we are able to remove the first roughness, meaning that we are able to achieve 1 micron in RA. So meaning that the objects are really, really smooth. But at the end, if you want to mirror finishing, you have to polish them. At the end, you always need, hand touch to have the complete mirror finishing. So, but at the end, as Alejandra was saying before, and I can confirm that the surface finishing that we are able to achieve with this technology is really high compared with, I don't know, laser technology that is really rough, the surface, or other technology. Yes, the finishing is really good.
Excellent. Well, I think that's our time up for the day. I'd like to thank you all, Alejandra, Thomas, and Fabio. That was excellent information today. Thank you all for joining us. The webinar will be available to download later for all those that have registered that haven't been able to join us today. And I'm sure if people want to ask questions of our 3 presenters, they can do so by contacting them via these details afterwards. And thank you very much for joining us.
Thank you.
Thank you, everybody.
Thank you, everybody.